Okay, so continuing on for the section of dial plan, but more specifically, dial plan as it's applied in UCME, we're back on the three routers, router 1, 2, and 3, which are our corporate headquarter, branch 1, and branch 2 routers, and they're all three running CME. So show telephony, actually let's do show run begin with voice. Well, actually let's go ahead and do begin with telephony. So we have our skinny based configuration, the minimum configuration being the max ePhones DN, IP source address, and create CNF. And then our optional configurations such as date and time format, time zone. I have system message your current options so that all the phones look at the bottom of the display. They have your current options just as they would if they were registered in UCM. And I also have the service phone web access. So it was web access, as I had mentioned, but I needed to grab the service and then apply a particular service to the phone. And I actually need to enter a value of 0 to turn the web server for each individual phone on, and a value of 1 turns it off. Why? I have no idea, but that's the way it is. So I had to enter that value. So that particular configuration has been added to the actual phones. Whoops. So I've got my, to their configuration files. We'll take a look at those in just a moment. So I also have ePhone DN1, number 1001. I've got a name assigned, and I've got that assigned to an ePhone, button 1:1. Now, previously I had created ePhone DN2 and ePhone 2. However, I then remembered that the second 7961 that I have here in my network is already running the SIP firmware, and I didn't really want to have to wait, however long, 30 minutes for it to download the new firmware across a WAN, across the internet and VPN actually, in order to change it to skinny. So what I did was just took advantage of that and went ahead and created show run pipe to begin with voice register. I went ahead and created my SIP-based CME. So voice register global, as we talked about in CCNA voice, is roughly analogous to the telephony service. So, but for SIP instead of skinny. I have it in mode CME versus mode SRST. SRST is the default mode, by the way. I've got my source address pointed to my loopback, max DNs, and pools or phones. And the reason in SIP that it can be a pool or called a pool, in the skinny-based phones in CME, I can only have one phone per ePhone. Okay, whether that's doing the traditional mode of CME or even CME as a form of SRST. We'll recall that SRST means survivable remote site telephony. So at a remote site, that is a site that is not local to the UCM main cluster, if we have one, which we haven't really got into yet, then if the WAN link should go down, or just access to the Unified Communication Manager call processing node should go down, then the local site has survivability. It can survive that WAN outage, and it can register phones locally. So that's what survivable remote site telephony, or SRST, is all about. With SIP-based phones and the default mode of SRST, multiple phones can actually register within a given pool. Okay? However, in mode CME, we typically take one pool per phone. So I have to configure also authenticate register. I have to basically be an authentication server and a SIP registrar server. Tell them to authenticate, create profile, just like create CNF for skinny. Voice register DN is roughly analogous to ePhone DN, but for SIP. And as I mentioned, voice register pool is our actual SIP-E phone. Whoops. So I've got my 7961 phone, my username and password. By the way, SIP phones must register with a username and password. So we have to create the username and password. That gets put into the SEP. In fact, let me just do show voice register TFTP bindings. That gets put into the SEP MAC-address.cnf.xml file. And then that file is when the phone requests that particular file, which it will always request SEP, its own MAC address, .cnf.xml. When it requests that file, we serve that file through TFTP. It then receives that file, and then it tries to authenticate using the username and password. So it's important that SIP phones, particularly in CME, have that username and password in order to be able to register to the system. So then they use that username and password to try to contact the server, and it already has the configuration. It was the one that created it in the first place, and we're able to register. Now, we'll be talking a little bit later in two more sections after Gatekeeper about something called Cisco Unified Border Element, or the old name was IP to IP Gateway. What this means is that, and we talked earlier about this in the voice gateway section, the idea is that I've got always two call legs, but that both of my call legs, both my inbound and my outbound, are both of the type VoIP. Now, if I have a number of dial peers, such as show voice register dial peer, so here is my 40,001 VoIP dial peer. If let's say I have multiple SIP phones and I want them to be able to call each other, that means a call would come in on a voice over IP dial peer, and it would also leave on or inbound and outbound on both voice over IP dial peers. In order for that to occur, I must turn on Cube functionality, or Unified Border Element, or IP to IP Gateway. All the same thing. So that occurs, show run pipe 2 section. Actually, let's just do begin with voice service. That begins with, first of all, two voice over IP dial peers, and then the command allow connections. So for two SIP phones to talk to each other, we need allow connections, and this is the inbound call leg to the outbound call leg. So two phones would need allow connection SIP to SIP. If we want one of those SIP phones to talk across an H323 trunk. Now you might say, how can a SIP phone talk across an H323 voice over IP dial peer or trunk? Well, because of Cube, the Unified Border Element, or the IP to IP Gateway. That is, the signaling from the phone to the system will be inbound through SIP, and that is the system that will take and translate and transfer any of the settings from the inbound SIP dial peer to the outbound H323 dial peer. Vice versa, if a call came in on an H323 dial peer and wanted to leave to, let's say, a SIP phone, or maybe I even had two H323 VoIP dial peers, inbound and outbound. Now, I don't need to turn on all four of these unless I'm using them, but it probably can't hurt unless, of course, you're dealing with some form of security that you need to keep in mind. So I also have, under voice service VoIP, the SIP command. And so under the SIP subsection, then I'm binding all source, well, really all SIP traffic that is coming from the router, that is sourced from the router, will be sourced from loopback 0, both control and any media that results as a result, I suppose, to be redundant, of the SIP protocol or SIP setup, SIP invite. Okay, so media obviously isn't part of the SIP protocol in the sense that media isn't, we don't use SIP to transfer to actually transport media, but we do use SIP to set up the media. So we can inform the SDP, the Session Description Protocol, where to bind the setup for the media from whatever interface from the router. And then we have to actually turn on the registrar server. So when down here I had voice register global authenticate register, I'm telling the phones that they must authenticate with the registrar server. Okay, and that's where that username and password came in, under the voice register pool or phone. But then here globally, I'm actually turning on a registrar server. I'm making myself into a SIP registrar server. Now, anytime I have a sort of a voice over IP dial peer, which is of course what the voice register DN and pool together create, I have to deal with codec. So I could leave it at the default codec. I could hard code just a single codec support for that phone, or I can use voice class codec. So here I'm calling a predefined class of codecs, and if I scroll back up, I see that I've actually already predefined one. So I've predefined voice class codec 1, and by the way, you'll take note of voice space class space codec here, and then down under the actual application, it's voice dash class space codec, and then the tag. The reason for that, and this is very common throughout iOS, is that the application has a dash in between two words, and the creation has a space in between two words. And the reason for that is basically that if I was pasting in or just typing in a number of commands, that no matter where I was, if I type voice space class codec, then it's going to jump me back out to global configuration and apply whatever configuration I'm doing under voice class codec, the actual global setting. If I type voice dash class, I'm applying it, or I had better already be, under a particular voice over IP dial peer, or in this case, the template which creates the voice over IP dial peer being the voice register pool. So what I'm saying here with this voice class codec 1 is that my first preference is the G711 MULA protocol. My second preference for any communication is ILBC. My third is ISAC, and I can set the bitrate if I want, and the frame size. And my fourth is G.729R8, so no annex. Now, of course, I could rearrange these however I want. That's just how I decided to go ahead and configure them. Okay? And we'll take a look if I'm going to be setting up, and I will in a moment, if I'm going to be setting up dial peers between each other, so voice over IP dial peers, then I'm going to probably not want G711, a very bandwidth hungry codec. I'm probably not going to want to negotiate that over the WAN. That's not a problem. I've just set up one particular voice class for codecs, and I've assigned it to the phone. So if the phone goes to talk to any other devices, it's going to prefer G711 MULA. However, if it's leaving to talk out of a voice over IP dial peer, I'll probably create another voice class codec, or maybe I'll simply hard code it to a particular codec, such as G729. And then I will only allow that codec to be used rather than negotiated. Okay, so at this point, I've taken a look at my dial peers for my SIP dial peers, my 40,000 series voice over IP dial peer. Let's take a look at my ports for voice register for SIP. Oops, that's right. I don't have ports because a voice over IP dial peer doesn't have a port. It has a session target. Now, how did it know what the session target was? How did it know to go to 177.1.11.25 : the port number, which for UDP is 5060? How did it know? This is the voice over IP dial peer. If I do a show run, in fact, let's just do a show run pipe to begin dial dash peer. I don't see any return. Why? Because there are no dial peers yet in my router, in my voice gateway. So what is the, where am I getting that dial peer from? As we talked about earlier, it's dynamically created. Show dial dash peer. Well, actually, I'll show this command in a moment. But it's created by the voice register pool in DN. So likewise, I can do a show telephony service dial peers. And I see that I have my 20,001 and it's POTS. And if I do show run pipe to section ephone DN, I see that 1001 $, remember $, is a regular expression indicating the end of a string or end of a line. It put that in. The system created the dial peer. It put the $sign in. And it's a good practice. It simply prevents from, if there are any sort of overlapping numbers, it prevents from that interdigit timeout occurring. So if you dial 1001, the system has enough digits and sees that it not only has enough digits, but no more digits can be added to the string and routes the call to port 5001. And we see that 1001 was created as a result of ephone DN1. Likewise, if I do show telephony service port, here we do have ports. Oops, sorry, voice port. Here I have voice port 5001. Now, it doesn't necessarily say under voice port 5001 the IP address of the phone. But if I do a show ephone, I do see that I have this particular registered ephone, this MAC address, which is a result of the ephone, because I put the MAC address under there. And it does have a knowledge of the IP address. So this eFXS port, this virtual FXS port, is linked in the database. It just doesn't happen to be under the show voice port or show telephony service voice port command. I do see the IP address recorded in the database. So it does know where to send the call. And it does realize this is an IP, first of all, IP, not only the IP address, but the fact that it's IP, but it knows to choose a codec. G711 MULA is the default. We can set the codec under ephone proper. I also see that this has button 1, DN1, which happens to be number 1, or I'm sorry, number 1001. And it has channel 1, which is idle, all the way through channel 8, which all of them are currently idle. So this DN tag 1, which is number 1001, has 8 media channels. Okay, I could also do show voice register pool. And I can see that pool tag 1 is configured with an IP address, and I have the type. Whoops. There we go. The dial peers that were created, and then here's what I was looking for, the active registration. How many SIP phones are registered to this pool? 1. Okay? And it gives us information about the number of requests, success, failures, etc. So I've got this done. Over at branch 1, router 2, I have an ephone registered with DN 2001. And over at router 3, branch 2, I have 2 ePhones registered that are both skinny, and they have DNs 3001 and 3002. So I'm going to go ahead and clear off my screen at each of these. And we're going to begin on our dial plan. So to begin with, let's just go ahead and bring up our config T, global config mode, and we're going to say dial-peer voice, and we'll just start with, let's say, 1 POTS, And this is where we can choose the type, voice over IP, which is that, and POTS are the most common, multimedia or multimedia mail. And then there's also voice over ATM and frame relay. We certainly won't be putting any voice directly in layer 2. Okay, so we jump into our first dial peer. And actually, before we do anything with dial peer, we haven't actually even seen if we have our PRI or T1 CAS or FXO or FXS set up. So let's first do show inventory to see what we have available. On this particular router, we only have a PVDM248, so running on 3 DSPs. And we have a first generation VWIC with 2 multiflex trunks in T1 configuration. So if I do show run pipe to begin controller, I see, there we go, second time controller showed up. I have controller T1000 and controller T1001. So if I was to look back at the show inventory, I saw that it was on slot 0, sub-slot 0, so that's where the 0, 0 came from. And then the third 0 and 1 are ports 1 and 2, respectively, on the card. And I can see that the second port has already been set up as a channel group. This is a data group. So I know that this created a serial interface, which is serial 001 or 0/0/1 :0, and that indicates a data channel. And if I go ahead and hit space a couple times, I certainly do see serial 001 :0. It has no IP address, but that's because it has a sub interface where it actually has 2 sub interfaces so that I can break apart my various frame relay interface DELCs, say deliver any traffic that's destined to DELC 101 to this interface. Here's my IP addresses. So this is my hub. Router 1 is my hub of my hub and spoke configuration. And actually, we'll create a fully meshed configuration in a little bit. I'll create one for the PSTN or another PVC link on the PSTN so that we do, in fact, have a fully meshed configuration on the PSTN between routers 1, 2, and 3. But currently, we have a hub and spoke configuration where both branch 1, router 2, and branch 2, router 3 go back to corporate headquarter, router 1, as we saw in the diagram here. I had already updated the diagram to include this third fully meshed PVC. So I will go ahead and add that in a moment. But this PVC 301 is not yet in there. So if I look at router 2, I only see DELC 101. Let's go ahead and switch over, show frame relay DELC, or actually let's just do show frame relay map. I've got DELC 101. Yeah, let's go ahead and do show frame relay PVC so we can see all the permanent virtual circuits that are coming in. I see DELC 101, its status is active, but I have no more DELCs. Same with show frame relay PVC over here in branch 2. I've got DELC 201, but no others. Router 1, show frame relay, or do show frame relay PVC. I have DELC 101 and DELC 201. Okay, so back to our drawing. I've got this PVC brought up. And I've got this PVC brought up. I will in a moment bring up this third PVC, and that's simply a frame relay switch command on the actual WAN router. And our WAN router does happen to be also the same router that we're using as our PSTN. It's performing dual duty. Okay. So getting back to the controller, our first controller is currently doing nothing. So we're going to go ahead and jump into that controller interface and issue some commands. Now, before we issue framing and line coding, let's just do show controller T1,000 and see what it's set up as. It's currently set up as framing is extended superframe, and line coding is bipolar with 8-0 substitution. And the clock source is provided from the line. We also notice that we have a lot of slips. Slips are typically a result of bad clocking or the clocking not being received. So we're going to see how to clear those up in a moment. So first of all, I also have some information here, such as loss of signal. That alarm is clear. Loss of frame. That alarm is clear. But notice that I have, this is data in the current interval. I don't have any line code violations, so my line code is set up proper. But I do have slips, and again, that indicates clocking, and that's in data in the current interval. So 54 seconds have elapsed since that reading was taken. Data in interval 1 was taken a little while ago, and I had 48 slips. Then I have data in interval 2, 46 slips, data in interval 3, 47 slips, and we can see that this is a common trend. So it looks like there's about 46, 47, pretty consistently 47 once we get beyond 3 readings taken in a given interval, and I had that many errors and slips. So I have continuous slips going back, but this is in the past. So even once we fix the issue of slips related to time, I'm still going to have errors in the past. What we will be looking for is data in the current interval being without any slips or errored seconds, and then beginning to fill up the history buffer as far as no errors. And eventually it will replace everything with 0 slips. So we've got the proper framing and line coding. Well, that is, the carrier told us, and what is currently, I should say, what is current for North America is B8ZS and ESF. So that's what's the default. So that's nice. So that being the case, also clock source line being the default. Anything that's default, you probably already know from CCNA that that's not going to show up in the router configuration. So again, do show run pipe to section controller T1. I don't have anything related to framing, ESF, or clock source. If I did say something like clock source line, it still wouldn't show up. If I said something like clock source internal, all of a sudden that configuration would show up. So at this point, I'm going to go ahead and issue a PRI group, because that's how our carrier has sent us an email saying that's how they're provisioning the trunk. Well, in this lab environment, that's how I, being the carrier, provision the trunk. Coming in is as a PRI versus an older T1, T1 digital CAS circuit such as E&M or some other type of signaling on that. And the reason, of course, is that PRI carries a lot more information, and so we can do a lot more with it, and we can troubleshoot and see a lot more. So I'm going to create PRI group, time slots, and I particularly, let's just say I'm going to do 1 through 6 on this particular router. So I'm only going to create a fractional T1. And whether I put in the data channel, comma 24 or not, it will add it for me. So I don't have to worry about that. And I could add on NFAS if I was bundling a bunch of PRIs together. I'm not. Or service if I wanted to add on service MGCP to be able to link this particular PRI to a call agent like a UCM, the big communication manager. We obviously are not doing that yet. We will come back and reconfigure our routers and take off CME on at least a few of them, probably on all of them at some point. But for now, we're just using CME. So we're not going to use any MGCP. We're simply going to set up PRI group time slots. And it tells us that the switch type must be set globally first. It doesn't say globally, but it is. So ISDN switch type, and this particular switch, the carrier informed us, was NI, or national. So I'm going to jump back into the controller, and I'm going to issue the PRI group time slots command again, and I'll notice that ISDN 000:23 1 through 6 just changed state to up. And I see that they're actually referenced as :0, 1, 2, 3, 4, and 5, counting canonically as the B channels. These are the B channels, the bearer channels that bear the voice or video. And this is the D channel, :23. Now, if I go back and do show run pipe 2 section controller, again, here's where I see 24 is the number of the D channel on the controller interface. But if I begin looking at my serial interfaces, it calls this D channel :23. So that's what I was talking about earlier when we mentioned one place in iOS counts canonically and the other place does not. So it copied from global the switch type, and I could change it here. And again, this gives me the ability to have multiple PRIs in a given router and have different ISDN switch types. It also automatically turns CDP off, and CDP being a layer 2 protocol, and turned on ISDN incoming voice of type voice. Encapsulation HDLC and no IP address. These are all default configurations. It also created a voice port. Okay, so this is not the D channel, but it is all the information related to that comes across on the D channel related to calling number, calling name, all that information. Now, whether certain attributes or information elements are supported, such as are we going to support calling name, that we would do, or what types of calling number, called number, redirect number are we going to support for the ISDN. That bit we do, whoops, too far. That bit we do under the serial interface, which is the D channel. Anything related to actual manipulation or viewing or anything like that of the numbers that come in, that's what we do here under voice port. So anytime we want to change the information or manipulate it as it comes in or goes out from or to this PRI respectively, we do it here. Anytime we want to support or turn off support for a given feature on the PRI, we do that here under the serial interface. Anytime we want to route a call to that PRI, we reference the voice port here. So we had to really create that before we could begin at least some of our dial plan. Really, our dial plan isn't going to do anything until we have that particular information there. So let's just do show dial-peer voice summary. And I see that I have, well, I created dial peer 1, but I didn't really do anything to it. So if I do show run pipe 2, begin, actually let's just do section dial-peer. I have the command dial peer 1 pots, but it has no configuration for inbound or outbound associated with it. I have my 20,001 and 40,001, which are virtually created by the system for skinny and SIP phones respectively in CME. But I have no other dial peers defined. So what would happen if I were to do a debug ISDN Q931 and also a debug voice, actually let's do debug VoIP dial peer. And by the way, even though debug VoIP seems like it's just going to do voice over IP dial peers, it actually will debug POTS dial peers as well. So I've turned on two debugs, being dial peer and Q931 or layer 3 information from an ISDN call. So let's go ahead and clear off our screen and our scroll back. And I'm going to place a call in from the PSTN. And I've actually gone ahead and brought the PSTN phone up from my Verify Insight window. So I'm going to tell the PSTN to go off hook on line 1 and dial, let's see, 206-501-1001. And I went ahead and I'm going to, as I do my first dials on each of the phones, turn up the volume so hopefully you can hear a little bit about it. But the phone actually did dial. I'll refresh the screen here. I've gone ahead and subsequently hung up, but the phone did dial. It met with a busy tone, and in the background we saw some information. So let's go take a look at that information. So we see that under our ISDN serial or D channel 000:23 that we received a setup message from the PSTN. How do we know it's from the PSTN? Because we received it. We were given some information about the trunk, such as CCIT, which is basically PCM, MULA. The transfer capability was speech. We're in a circuit mode, 64 kilobit per second for the B channel. Which channel? B channel 1. So it's sending us beginning with channel 1, and this is counting non-canonically, so not beginning with 0. There was a display IE, which was Seattle US phone. So there was actually a name, calling name that was associated, and the string was Seattle US phone. The calling party number had, and maybe go into these information elements later, but basically it had the number of 206-501-5111. And if I pull back up my phone here, you can, I'll blow this up a little more, you can see that the first line, at least it has the label of +1 206-501-5111. So that's that line. It's just that the PSTN is not configured to send in the +1 as part of its calling number. It's only configured to send in 10 digits, at least if it's coming in locally. Now, if it's coming in internationally, I have the PSTN set up to send the country code as well. So if I had picked up line 3, let's say I go off hook on line 3, and then I dial this number, and let me hang that phone up, then you will have seen, once I scroll back a bit, that line 3 was 31 was the country code, 20-703-7333, and that's how the calling number came in, was 3120-703-7333. So when it was coming in from an international type number, it had the country code as well. And that's typically how calls come in to most gateways, is that in the US, they come in 10 digits, which are the E164 number, but not including the country code or any national prefix or anything like that. And in most other countries, and that is, I should say, if the call is local or from a national place. And in most other countries, calls come in if they are local to that city or even national within the country, they come in with a 0 and then the city code and then the rest of the subscriber digits. If they are coming internationally, almost anywhere, almost every carrier sends in the country code, then the city code, and then the rest of the digits. So let's go back and continue looking at our initial call. We could see that the carrier tagged the plan as ISDN and type as subscriber. We're not going to go too much more into that, other than I'll just say briefly, there's a number of different plans and types, but the main ones that we'll focus on is the plan of ISDN and the type, the 4 types of actually subscriber, national, subscriber, national, international, and then simply unknown. There are others, but those are the ones that we'll focus on, but we really won't come back to those too much until maybe CIPT1, but definitely CIPT2, where we get into multi-site, multi-cluster UCM, large-scale international deployments. We're doing international now, but just with CME, and so we're not too concerned with anything related to something called globalization yet. So that was part of the Q931. We had received the setup, and we had tagged a call reference number and call ID. We know it's switch type. We know that we're the interface user rather than interface network. And now we actually see the debug VoIP dial peer kicking in. So we have the calling number and the called number extracted from ISDN, and we're trying to do a dial peer, DP, dial peer associate incoming peer core. So we're trying to match an inbound dial peer. And we actually, if we scroll through, I'm not going to go through everything at this point. We'll look a lot more at these debugs in depth on CVOICE, troubleshooting voice. But for now, I can quickly see in English, result no match. After all rules attempted, I did not match an incoming dial peer. Okay? So I have no way, basically, if I can't bring the call into the router, if I can't bring it in on a particular dial peer, it's almost like saying if I had an IP packet that hit my my router, but I didn't have an IP interface on which to allow it to come in. Now that kind of doesn't make any sense, because if I look at the IP world, I can't have an IP packet hit my router unless I have an IP address. And if I have an IP address, I have an interface, so it had to come in there. So in the voice world, we actually have the ability for our voice. I'm not sure where that just came from. Maybe one of the phones just re-registered, but I don't think there's been any other calls. But in a voice world, I actually have the ability for the call to come in through the voice port, but which we saw with the debug ISDN Q931, but there was no inbound dial peer, the logical entity that says what to do with the call. So if I don't know what to do with the call, I don't know where to route the call. You know, actually, a good analogy would be, to the data world, a frame coming in from frame relay. So it comes in on the frame port or frame interface, but I don't have a layer 3 IP interface. So the call came in, if you will, almost on the layer 2 interface, the voice port, but then it didn't have any layer 3 interface to really route with. Now I realize I mentioned earlier that ISDN has a layer 3 component, but try to allow for the analogy. So what I need to do is I need to go back into global config, go into dial peer voice 1 that I had already created as a POTS type dial peer, and I need to say incoming called number dot. Now remember, if I don't put a $sign, I'm saying any additional digits will match. So now, any calls that come in from any sort of POTS. Now I didn't put a port number. Remember, the matching of inbound calls comes first through incoming called number. That's what it tries to use to match first. Next, I don't know where these calls are coming from. Outgoing dial peer. It's like one of our phones is dialing on its own. No, 40,001 is 1002. I think it's just re-registering, and as it re-registers, it's sending basically the called information or the phone information. But at any rate, remember first that it matches incoming called number, then it tries to match, and that matches called number, DNIS. Then it tries to match answer address, which matches on ANI or calling number. Then it tries to match destination pattern for an inbound call matches calling number, ANI. And then lastly, it tries to match port. So we now have we now have a dial peer that matches all inbound numbers regardless of what port they come in, as long as they come in on a POTS type voice port, which includes the only POTS voice port that we have. So I'm going to clear off the screen and scroll back, and let's have that call come in again. Okay, now the call came in again this time, and I went ahead and hung up the call. But this time, let's go ahead and scroll back. And see if we match an inbound dial peer. This time, after dial peer match, incoming DNIS, we do have an incoming dial peer, and that is dial peer 1. So now we've matched an inbound dial peer. The problem is, at this point, we don't have any place to route the call to. So the destination is not set up. So we have the inbound dial peer, but as we scroll down, and again, we'll take a look at a lot more of this information later. Part of this is actually the SIP phone that keeps re-registering or doing a re-register for our outbound dial peer. No outgoing dial peer is matched. Result, no match. So here's what had happened with the rest of the ISDN message. We transmitted as we were looking for a way to route the call. We had transmitted a call proceeding, and in particular to in reference to a particular call reference number. And then after we couldn't route the call, we transmitted to the PSTN disconnect because of the cause code unallocated or unassigned number. The PSTN sent a release, we received it, and we transmitted the release complete. Okay? The rest of that is just the SIP phone re-registering. So now we need to have some sort of a outbound dial peer. Now you might say, let's say show dial peer voice sum. You might say, well, we do have dial peers that should match the outbound. Oops, sorry. We have destination pattern 1001. Well, what were the digits that came in? Let's do undebug VoIP dial peer for just a moment. And let's leave the debug ISDN Q931 on, and I'm going to do this call again. And so the called number was not 1001, it was 206-501-1001. And as we looked at our dial peer summary, we don't have a place, or we don't have any destination that matches 206-501-1001. We don't have anything that begins with 206 at all. And 1001, so that's the only thing that we have that's close, but it's not going to work. So we're going to need to transform that number somehow. There's a couple ways that we can do it. One, we can do it with something called a voice translation rule. We'll get into that in a moment. For now, we're going to look under telephony service at something called the dial plan pattern command. So we're going to issue a string tag. This is just an index number. And we're going to represent a sequence of digits or a dial plan pattern. So if we know that all calls coming into us, we have the 206-501-1 ... DID set of numbers, so the 1000 series of numbers, I'm going to go ahead and say that the pattern is 206-501-1 and then ... Remember, in UCM, we'll say XXX. In iOS, we'll say ... to indicate sort of a mask, basically meaning wildcard digits. Any digit could apply for those last three. Then we'll say question, so what's next, and extension length. So how long are the extensions that we want to transform these numbers? And actually what this is going to do is not so much transform the number, but basically take a look at all extensions that are X number of digits. So our extensions are 4 numbers in length, and they begin with the extension pattern of 1 dot dot dot. So what that command has done is gone back and looked at the skinny-based dial peers that have already been created and said, how many 4-digit extensions do I have that begin with 1? And so every 4-digit extension I have that begins with 1 that's a skinny phone, I'm going to create another dial peer for it. So if I look at my dial peer voice summary again, I now see that I not only have 23 POTS dial peer, and it is 206 501 1001, and it maps to the same port, 5001, just like this does, 5001. So that's great. So now, if I do that same call again, I should have an outbound dial peer that matches. That call should route. So let's go ahead and actually make sure I haven't brought up my skinny-based IP phone in CME. So let me go ahead and do that. So here's my 1001 phone. And I'm going to make that just a little bit smaller. And I've got my PSTN phone. So I'm going to dial again, and this time the call should actually show up as ringing. Okay, kick off the call. And I can hear and I see that the call now is coming in from, and I'm going to answer the call and hit mute real quick so I don't get a bunch of feedback since these two phones are physically right next to each other. But now I have a call that is nailed up from the Seattle US phone from 206 501 5111. The call came in. We see the calling party and the called party just as they were before. We transmitted the call proceeding. Remember, before we had transmitted a disconnect because of unallocated or unassigned number. This time we transmitted alerting. We found the phone, is what we're telling the PSTN, and we're ringing it. And then once the person answered, and you remember from the call flows yesterday, once the person answered, then we transmitted to the PSTN, we've connected. And they say, connection acknowledged. And now the line protocol on serial 000:B channel 1, or counting canonically 0, has now changed state to up. If I do show ISDN status, I see that I have one active layer 3 call. Okay? And that call is a voice call. Which B channel is it on? It's on B channel 1. By the way, for layer 2, layer 1 is the framing line coding, mainly the framing. Layer 2 is the terminal endpoint identifier. And so if state equals TEI awaiting establishment or terminal endpoint identifier awaiting establishment, then that means something's wrong. We haven't configured it right. Maybe we have the wrong switch type or something else, but we are not meshing with the carrier's settings. And so we don't have a actual layer 3 state up for our ISDN. When we get to the layer 2 status of multiple frames established, that means that our layer 3 has now come up. Remember, layer 2 is Q921, and we can debug that if we want. And layer 3 is Q931. Okay? It's important that you remember those specifications because that's actually what we use to refer to them all the time and what we actually refer to in the debugs. Debug ISDN Q921 for layer 2, debug ISDN Q931 for layer 3. Okay, so we've got our call nailed up. Anytime I go ahead and hang up this call, as soon as I hit it, even if the screen takes a while to refresh, behind you saw the disconnect. We disconnected from that call. It lasted 173 seconds. We transmit a disconnect to the PSTN with the cause code. We always provide a cause code when there is a disconnect, whether it's because of an error or because of a normal call clearing. In this case, we receive a release from the PSTN and we transmit on the layer 3 Q931, we transmit a release complete. There's always an acknowledgement in voice. Okay, so we have a call routing. Now, what happens if that PSTN, instead of dialing, and I just refreshed the screen, so give it a second, instead of dialing 206.501.1001, what if it dialed 1002? Let's see what happens. Now, you can probably hear it in the background, the reorder tone, and that's because of unallocated or unassigned number. So let me just turn this off real briefly. Kill that call. Okay, so the unallocated or unassigned number when we went to the called party of 206.501.1002. Now 1001 routed properly. Let's look at our dial plan again. Show dial peer voice summary. That dial plan pattern command, as I mentioned, only looked to skinny phones. It did not do anything for SIP-based phones. So I need to do something for SIP phones. And what I'm going to do is going to go ahead and cure any skinny phones as well. So I'm going to first jump into telephony service, and I'm going to say no to that dial plan pattern command that I had just created. So do show dial-peer voice summary. I see that what was previously there is dial peer 20003. I just got rid of. Okay, I did a no to the dial plan pattern command, and I'm going to have to solve this problem in another way that handles truncating or manipulating the digits from 10 digits down to 4. So we're going to talk real briefly about voice translation rules, and we're going to come back to these in a lot more detail later. But for now, we're just going to introduce the beginning of something called voice translation rules. Now I have a translation rule and a translation profile. I create translation rules and I put them inside of translation profiles, and then I apply the translation profiles. It's very similar to, if you're familiar with QoS, and we're going to be discussing that here in CVOICE, that is, we create class maps, we put them inside of policy maps, and then we apply the policy maps. A lot of things in Cisco use this kind of 3-step hierarchy of something points to something else, and that something else points to another thing. So we nest entities within other entities. The reason that Cisco does this is because it gives us great scalability. We can reuse objects in multiple different places, and they can serve more than one purpose. It may seem overly complex at first, but you will get used to it, and it's the way Cisco does things. And again, it's for scalability. So I'm going to create a translation rule. Now, this is called a translation rule, but it's actually a rule set. Meaning I'm going to create translation rule set 1. Within the rule set, and you saw my prompt change, I now have rules. So it's kind of redundant to say translation rule 1 and then rule 1. Okay? So the actual parent is actually what's known as a translation rule set. It just doesn't say that right there. When we do a debug for this, which is debug voice translation, we will see that it's actually referred to as rule set 1. And it's a set of individual or a set of multiple rules underneath of it. And we can either create a matching pattern or we can do something like a call block. And we're not going to deal with call block yet. So to begin with, we see that the word or string must be within 2 forward slashes. So we have to create 2 forward slashes, and back our cursor up. Of course, you don't have to do it this way, but to begin with, I recommend it. And we're going to create matching string within here. So that would be an example of a matching string, matching the specific string of 1001 within those 2 forward slashes. I'm going to come back and change that in a moment. Once we've done the matching string, I'm just giving an example here to begin with, not the actual solution to our current problem. We are going to have a space, and then we're going to have 2 more forward slashes with a word or string in between. And this word is really a digit pattern. And so we had the matching pattern to begin with, and then the replacement pattern or translated pattern. So here we have another set of forward slashes, and I do something like this. So right now, if I applied this somewhere and it was in the proper place, if you dialed 1001, it would transform it to 2001. So the 2 forward slashes are simply what are known as delimiters, but there's something that the iOS requires us to put in. You don't really have to understand why per se. Look up the word delimiter if you don't understand it, but you simply do have to accept it. Okay, so I'm going to go ahead and back up, and I'm going to put in our actual replacement pattern. So our actual replacement pattern, we want it to be 206, 501, and what was our called number? 1 ... And we want to transform that to 1 ... Now, without going into too much of the theory, I am going to basically go into a little bit of the theory of voice translation rules, and that is that I need to create a set. We talked yesterday about a parenthesis around a pattern of digits in something like a dial peer in destination pattern or even answer, address, or anything else, and how that created a set of characters, or I forget what we referred to it as yesterday. I always call it a set. And by the way, if you happen to have a Unix background, this voice translation rule you're probably seeing is predicated on or built on the logic of sed, the serial editor. At any rate, you don't necessarily have to know that. I wouldn't necessarily go back and look at Unix sed to get this. I would look at Cisco's voice translation rules because they are different. So I currently have a set, and this is very standard with a regular expression, with any regular expression really. So I've got this set, and in order to have those parentheses in there, which are sort of special characters, I have to I have to escape them. So I have to do what's called a backslash in between or before the open parenthesis, and then again before the closed parenthesis. I must do that. So now I still have the string of 206, 501, 1, anything, but I've set 1, anything inside of a set, and I had to define those escapes in order to define the open and close parenthesis special characters. It's getting a little crowded in here, I understand. It could get much worse, so I'm trying to take it easy on you, believe it or not. So now I'm going to go to my translated rule. And the translated rule is going to be in 2 forward slashes or in between, and it's going to be a special operator, which is in the, let me go back, take one step back to say, in the matching pattern, a backslash indicates an escape. I'm escaping the next character. That is, I'm treating it differently. In the replacement pattern, it's not an escape, but a backslash indicates that the next number is the set that I want to call. So I had created this first set, counting non-canonically. I had created this first set, and I now want to call that set into the replacement pattern. So I've listed 206, 501, 1, ... but I've set 1, ... apart, or I've set it aside in a set, or, for lack of a better term, in set number 1. And now I'm calling set number 1 to be the replacement pattern. So effectively, I'm taking this 10-digit number and truncating it down to only 4 digits. Okay, so that's my rule. I also have test commands. I'm going to exit out, exit again, and I'm going to do a test command, test voice translation rule. Remember, I'm not testing this rule, I'm testing a rule set. So I'm testing rule set 1. In fact, actually, before I do this, let's show run pipe 2 section voice translation. So here's my actual voice translation rule. Rule set 1 contains only one rule. I can have multiple rules. I could have, I think currently I can have up to, in iOS 15, I can now have up to 15 translation rules. You used to only be able to have 10. At any rate, I'm now going to test voice translation rule set 1, and I'm going to say, what's my number that I want to try to match against my rules to see what happens to it. So I'm going to say 206, 502. Now that is not my number. 501 is my number. Okay, I'm entering 502, 1001. And I'm going to see that it did not match with any of the rules. That's because 501 is my pattern here, and here I put 502. So I just wanted to show you it not matching first, and now I'm going to go back and change that 2 to a proper 1. And now we see that it matched with rule 1 in rule set 1. I see the original number, and then I see the translated number. Translated number is 1001, which was what I hoped to accomplish. So now I'm going to go say voice translation, not rule, but profile. And I need to give the profile a name. With rule sets, you can only give them numbers. With profiles, you can give them names if you like. So I'm going to say voice translation profile. Let's say 10-digit DNIS, 4-digit. That's what I'm going to call it. And I'm going to say, I want you to, in this profile, I want you to translate what type of number. Is it a called and calling? Those are the two that we're most familiar with and that we'll keep looking at for now. But we do see that there are other things like callback, redirect called, and even redirect target. We'll take a look at those more as the class goes on, but for now we'll focus on called and calling. Which type of number is it that we want to translate? If we scroll back to our debugs, we're trying to get the call down to 1001. It's coming into us from the PSTN. Are we trying to translate the called number or the calling number? We're not trying to translate the calling number because that's the person that's on the other side. That's the calling party. We want to see who is the calling party. What we're trying to translate is how we route the call. And we traditionally route the call based on the called number. In almost every circumstance, we route a call based on the called number. You're going to see one tiny exception to that in CIPT where we can route based on calling. But 99.9% of the time, we're routing based on destination or called number. So we want to translate called number. And what do we want to translate called? We want to translate rule set 1 against the called number type. So now if I do show run pipe to begin voice trans, I see I've got my translation rule set, my rule inside that rule set, my profile, and now I'm calling rule set 1 to translate against called. This is now what I'm going to reference, and I'm going to reference that. I could do it at the how does a call come into a router? We've looked at this now a number of times. Our inbound call leg is going to be what? Our inbound call comes from, we said that there's always 2 call legs, but how it enters the router, if it's coming POTS, it comes first in a voice port, then it hits an inbound dial peer. Then it hits an outbound dial peer, And if the outbound dial peer is VoIP, then it goes to that session target. If the outbound dial peer is POTS, then it goes to that port. POTS always has a port. POTS always has a port. Remember that. VoIP has a session target, but POTS has a port. So I could translate this number at the inbound voice port, or I could translate it at the inbound dial peer. In this case, I only have one inbound dial peer, so it really doesn't matter which place I do it. I prefer to do it at the very first place that the call comes into the router. So I'm going to actually go to the voice port 000:23, and I'm going to say translation profile 10-digit. Now, actually, that's not correct. I now need to say, which direction do I want to translate numbers on? Do I want to translate calls that are coming in on this port or leaving this port for the PSTN? I want to translate calls coming in to this port. So incoming, I want to apply this particular translation profile. So you see where we can do different things at each level. The translation rule set is where we define the string to be matched and the replacement value. At the profile, we define what we want to translate. Do we want to translate calling or called type? And then at the actual voice port or dial peer, we decide direction. Do we want to do this against the inbound or outbound direction? So now, let's show debug. We've only got ISDN Q931 turned on, so I'm going to leave that, but I'm also going to do debug voice translation. So now we're going to make this call again, this time to 1002. We assume that if 1002 is going to work, then 1001 is going to work as well. We already saw the call work to 1001. Wasn't really because we were translating, but rather because we created a second dial peer that had the not quite full E164, but 10 digits of the E164 number in it in the form of dial plan pattern command, but it only worked for skinny devices. So now we're going to go ahead and dial the number, and we're not only going to see the call come in from ISDN debug perspective, but also voice translation rule debugging. So here goes the number. And I don't actually have 1002 pulled up. Sorry about that. You can hear it ringing, or should be able to. Whoops, I did not mean to hang up. I accidentally did. I'm going to go ahead and trigger that call again, and this time... Actually, let me do this. Let me clear off our screen and scroll back, trigger the call, and I'm going to accept the call. Okay, so I've gone ahead and accepted the call on 1002. In fact, let me just pull 1002 up. I have to grab the IP address of it in order to put it in my Verify Insight client and connect to it. It actually can't establish a connection at the moment because I don't have that web access turned on for that particular phone. I'll have to do that later. So I'm not going to be able to show you the actual phone right now. You can see that the PSTN phone, if I refresh this screen, is in a connected state, and I can see from show ISDN status that I have one active layer 3 call. I can even do something like show IP interface brief. Now, you might be familiar with this from CCNA. Show IP interface brief. I thought, Mark, you said these aren't IP interfaces, at least the voice ports. Well, I did, and they're not. However, because they do show up as serial interfaces, serial 000:23 being the D channel, and then 0 through 5, while they don't show up in running config, they do show up here in show IP interface brief. So they're not IP interfaces, but again, remember, a PRI could be used for IP. We could transmit data over it. We just happen to be doing capability voice over it. And that's what we will do for all of our class. But it could be a layer 3 data interface if we wanted. So I've got my 6 voice ports, my 6 B channels, my bearer channels, counting canonically, with my first channel in an up and up state, while the rest of them are down, down, except for the D channel. The D channel should at least always be up and up. But I've got one of my B channels up, and that's where my call is nailed up on, oops, again, show ISDN status on B channel number 1. So it's really a pain how some things in iOS count canonically, beginning with 0, and other things count non-canonically, beginning with 1. At any rate, let's scroll back up, and let's take a look. Here came the call in, and now we want to take a look at the debug voice translation. We found a profile defined on the voice port. It's really quite plain English, easy to read. Okay, we see that the voice port doesn't belong to any trunk group. That's fine. Trunk group is just a group of voice trunks all bundled together. Okay, currently, at least at the stage that it's at, doesn't have anything. There's no rule set for calling number found. However, for called number, we match with rule 1 in rule set 1. And we have a successful substitution. The original pattern was, as it came in, 206, 501, 1002. We matched the pattern 206, 501, parenthesis, 1 dot dot dot, end parenthesis. We replaced the pattern with \1, calling that first set, and then the actual replaced pattern was 1002. And then that 1002 is, of course, passed on to the inbound dial peer, matches incoming called number dot, so the inbound dial peer sees 1002. Why? Because we translated this at the voice port, which is before the inbound dial peer. Remember, it goes inbound port, inbound dial peer, outbound dial peer, and then if POTS, outbound port. And so 1002, if I go back far enough, or I could just type it in, 1002 is a destination pattern in a voice over IP dial peer, and so we send it off to that particular IP address to port 5060, even though 60 doesn't show up. Okay, so we send it off to the SIP IP address and port. And that phone call is currently nailed up, and when I go hit the speakerphone button to hang up, we see the disconnect, normal call clearing.